Excellent. Absolutely spot on.
No
Hopefully,
problem.
your timing is epic and Quantum Erasers is ready to rock and roll. Do you need to present your screen?
I didn't say I was ready yet.
Ugh, we haven't bought enough time.
I know you are. Okay, listen. Yeah, let's just do it. I'll present the screen. 1 second.
Okay, give me a second, then I need to set that up. So,
Okay.
I'll just present it to the Hangout as well, just because I'm that kind of guy.
Just let me know when it's up, man.
Yeah, just give me a couple more seconds.
Yeah. Take your time. We got 4 more hours.
We haven't. Think of it as though there's 4 more hours. Right, I think we're ready to go. Right, you're on.
Yeah. So late. I think it was late yesterday. Anthony brought or made a video about conspiracy cats. Right. I don't know if you guys are familiar with this one. I was checking it out later yesterday, but I was absolutely shocked at this. Now we're talking about an educated baller now, because conspiracy cats, he's not only educated, he's teaching your kids, right? Let's see what he has to say here. Conspiracy cats. The second law of thermodynamics is about the movement of energy, not the movement of matter. I nearly fell off the chair. I couldn't believe that he actually said that. I had to go back and listen to it a few times. What the hell is he talking about? Number one, from University Today or the universetoday.com. Number one, Einstein showed us light and matter are just aspects of the same thing. Matter is just frozen light, and light is matter on the move, right? Einstein's most famous equation says that energy and matter are two sides of the same coin. So what the heck are you talking about, conspiracy cats? I mean, you're an Einstein junkie, right? Number two, from the entropy site .edu. In classical thermodynamics, it is viewing entropy increase as a measure of the dispersal of energy from localized to spread out at a given temperature, right? In molecular thermodynamics, it is considering the change in a system or surroundings or their total, for which there are fewer accessible microstates to one for which there is an increased number of accessible microstates. I mean, don't you know this? Again, from the entropy site .edu, gas expansion into a vacuum. The mixing of ideal gases or liquids, diffusion, effusion, colligative effects, and osmosis each fundamentally involves an increase in entropy due to increased dispersion of energy with no change in total energy in the case of ideal substances, due to a greater number of microstates for the particular system involved. This physics teacher, he'd fail 6th grade intro to physics. I mean, I'm speechless. Wait till you hear this one. This is the last one, by the way. Conspiracy cats. The particles that have made it that high up in the atmosphere have already done so much work against gravity and have radiated off so much of their energy as heat that they have almost no energy left whatsoever. What? Are you on medication? Dude, have you heard this before? An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. You heard this before. Number two, this gets better. Gas particles are constantly colliding with each other and the walls of their container. These collisions are elastic. That is, there is no net loss of energy from the collisions. This is intro to chemistry, by the way. And by the way, where's the container? Too funny. Number three, the average kinetic energy of gas particles is proportional to what? the absolute temperature of the gas. And all gases at the same temperature have the same average kinetic energy. So, that high up in the atmosphere, crayon munching Mr. Magoo, is the thermosphere, where temps can reach better than 3,000 degrees Fahrenheit. They're gaining energy. And number 4, radiate off energy is heat to what? To what? Do you even know the 3 levels of heat transfer? Please explain that to us. And what happens to gases when they cool? After you answer that, then where's the liquid in the upper atmosphere? My word, sir. And number 5, gravity. We've been down this road before. Which gravity? Einsteinian or Newtonian? Then, is gravity a force? B, is gravity a scientific law or scientific theory? C, what is the cause of gravity? D, scientifically validate the one you choose. Here we go again. What natural phenomenon was observed? Post a formal scientific hypothesis, then experiment that validates your claim. Number 3, highlight the independent and dependent variables that were used in the test. Cite source. Post a null hypothesis that was rejected or falsified. Oh, never mind. From techtarget.com. A gas is a sample of matter that conforms to the shape of a container in which it is held and acquires a uniform density inside the container, even in the presence of gravity, and regardless of the amount of substance in the container. If not confined to a container, gaseous matter, also known as vapor, will disperse into space. Duh! In conclusion, if Catz would have said water is made from boll weevil salts, it would have been more coherent. For fuck's sake, man! Thanks for...
And with that, I'll say a huge, massive, enormous thank you to all of today's debating panel on both Discord, Skype, and indeed the Hangouts on Air regular panel members. If you are watching this on the Nathan Oakley premiering stream, then stay tuned, as there will be an after show to follow. Unfortunately, if you're watching this in the Nathan Oakley 1980 live stream, then this is where we bid you farewell. Be sure to check out nathanoakley.com and the Flat Earth Debate Forum to keep up to date with the community debate. I've been Nathan Oakley. Stay tuned if you're watching on the premiering stream, and I'll see you all in the next video.
Oh, what a day! What a lovely day!